This video is once again motivated by one of my students' questions recently, and this is actually a very common question that I get whenever I teach calculus. Okay, so the question is, well, they're given a problem like this. Find f prime of 2 for f of x is 1 over x squared using the limit definition of the derivative. And their question is, well, I learned this definition, f prime of c is limit as h approaches 0, f of c plus h minus f of c over h. And also learned this one, f prime of c is also equal to limit as x approaches c, f of x minus f of c over x minus c. Are they the same? Which one should I use? In which cases? So to answer the first question, they're exactly the same. And that's the short answer to that question. And I'll dive into more conceptually why toward the end of the video. And to answer the question, second question, which one to use, it just depends on the problem. It comes down to the algebra. Sometimes if you use this method, it's easier to do the algebra. Sometimes when you use this method, it's easy to do the algebra. It just depends on the function itself. And usually, just to give you a tip, this one is nicer than this one. Again, you'll see in this problem that in this particular case, this one's nicer, but usually this one's nicer because you can find the derivative as a function of x instead of at some value c. So if the problem asks you to find multiple values and not just f prime of 2, maybe you want f prime of 3 as well, f prime of negative 10, you can find all of them. You have the function, you can plug in different values of x. Versus this definition, it's at one specific value c of x, which is c. So usually I tend to use this one, but as you get further in the course, you don't even really use this anymore. But you do need the conceptual understanding, which I'll review at the end. So I'll first show you that these two should give you the same result. So an analogy that might help you kind of understand this a little better is, it's not a perfect analogy, but this is how I try to help students think it through. These two should give the same result because they're exactly the same. You can kind of think of it as like identical twins. They have the same DNA internally, but on the outside, maybe they don't look exactly the same. There's like, for even identical twins, they don't look exactly the same most of the time, right? Or all the time. They have like some distinctive features usually that you can use to help differentiate them. So this is kind of a similar idea. These two are exactly the same, but they look a little different on the outside. Okay, and again, I'll explain why they're exactly the same in a more conceptual level toward the end of the video. Okay, now let's get into solving the actual derivative value, f prime of 2. So I'm going to do it doing the two methods, and I'll show you that you should get the exact same answer in both cases, okay? So let's do method 1 first. So f prime of 2 is limit, pay attention to the notation if you learned this for the first time as well, limit as h approaches 0, f of c plus h. So let me just write f of 2 plus h minus f of 2 over h. My c is 2. I want the derivative at x is equal to 2. Okay, equals limit as h approaches 0. What's f of 2 plus h? This is where most students have trouble as well. Well, first of all, how do we get f of 2? We plug in x equals 2 into our function over here. Well, if it's 2 plus h, we just plug in x as 2 plus h. No difference. So it'll be 1 over 2 plus h quantity squared minus 1 over 2 squared over h. This is my f of 2 plus h. Again, for our input is x. The variable, we want to replace it with 2 plus h. Sorry, this line, 2 plus h. So wherever there's x, plug in 2 plus h. Simple as that. Okay, so from here, we gotta start simplifying because if you try to evaluate the limit, it'll be 0 over 0. No surprise. Okay, so the technique here, if you remember, is you want a common denominator. So limit h approaches 0 of, to get a common denominator, we need to multiply these two together. That's the easiest way, right? So it would be, this is 4, right? 2 squared is 4, so it'll be 4 minus, if I expand this out, it'll be, I'm trying to skip some steps here, 4 plus 4h plus h squared over 4 times 4 plus 4h plus h squared all over h. So I just combine these two into one fraction as that. Okay, and now see, this is where your algebra needs to be good. Exactly why. Okay, so now I can simplify this, distribute this minus sign to each one. Now I have a 4 minus 4, which is 0, so limit h goes to 0 of minus 4h minus h squared over, this is a complex fraction, but I could just move this h up to here, so it'll be 4h, 4 plus 4h plus h squared. And I could actually divide through by h, because I can factor in h up here, can I not? So if I divide through by the h, what do I get? I get minus 4 minus h over 4 times 4 plus 4h plus h squared. Now what happens if I plug in h as 0? Let's try. It'll be minus 4 over 4 times 4 plus 0 plus 0. Okay? This would cancel, so I have a 1 on top, so I get minus 1 over 4, and that's my answer. Notice my notation as well. I did not drop the limit sign until I plugged in h as 0. That's how we do it. Okay, so I got minus 1/4 over here. Okay, so again, notice you had to be good with the algebra. Here, I combined them into these two fractions into one. I needed a common denominator, so that's what I did here. And then you also have to know that you can divide through by the h. If there's a complex fraction, so I just moved the h up there as well. And this is just algebra over here. A lot of people struggle with the algebra itself. So that's why you spent all those years learning algebra 1, algebra 2, pre-calc. Okay, now I need my different pen. Let's try this method. We'll see that in this problem, this method's a little easy. You can see here, I need all that complex algebra, right? I will still need some of that algebra here, but maybe not as bad. Okay, so I want f prime 2. So let's plug things into a definition. Limit as x approaches 2, f of x minus f of 2 over x minus 2. Okay, so this is limit x approaches 2. F of x is just 1 over x squared. That's what we were given, right? Minus f of 2, that's 1 over 2 squared, which is 1/4 over x minus 2. Again, probably want a common denominator on the top. So 4x squared it would be, right? 4 minus x squared over 4x squared over x minus 2. Okay, let me rewrite this as 4 minus x squared over 4x squared, x minus 2. So it's not a complex fraction. I didn't do anything mathematically, I just rewrote it. Okay. Now I can factor the top. It's a difference of 2 squares. We know how to factor that very well. That is 2 plus x, 2 minus x over 4x squared, x minus 2. Okay. This x minus 2, sorry, the x minus 2 is here. I can force this top one to be x minus 2. I just factor out a negative 1. So limit x approaches 2 of minus 2 plus x, x minus 2 over 4x squared, x minus 2. Okay? So you would have been needed to see that. This is where, again, algebra comes in. Okay? So this now, what happens if I plug in x as 2? I would get minus 4 over 4 times 4. These would cancel, right? So minus 1/4. Oh, not a surprise. It's the exact same. Okay, so the algebra here was kind of similar to here, but it's not as bad as over here. And not as tedious. I didn't have to write as many things over here as over here. Okay, so as you can see, exact same. So remember my analogy? Their DNA is the same, but the outside looks different. The formula looks different, kind of like identical twins. Okay, so now how do these formulas actually come about? That's the conceptual level now that I want to review real quick to hopefully hone in the idea that they're the same. Okay, so let me switch back to this black pen. Let me start from over here. So derivative, the concept is it's the slope of the tangent line. So if I have some point here, let's call this my C, exactly. Okay, so I would have some f of C over here, right? And I pick a close by point. C plus h. This is c plus h. I'm adding some offset of h, a step of h to my starting point c. And h is small, okay? So this point, this y value, I'll write it over here, is f of c plus h, okay? So I want the slope of this tangent line here, draw in purple, okay? Something like that, okay? I can approximate it with this c plus h. So it would look like this. So clearly you can see it's approximation, right? The actual slope is this purple one, but the actual slope that I would get using this c plus h and the c point is this black one over here. Okay, so what is the slope of this black line, black linear line over here? Change in y over change in x. F of c plus h minus f of c over c plus h minus c. That is just h. It's just a slope. Change in y over change in x. Okay? Now what happens if I move this point closer? So h gets smaller. So what if it's over here instead? How does the line look? Looks like this now. This one right here. Sorry that I don't have a different color, but it's this one right here. Isn't it much closer in slope to this purple one? Right? So hopefully you get the idea. That's why as we move this point closer and closer, the slope of that secant line will start getting closer to the slope of this tangent line. Okay, so that's where the limit comes. The limit as h approaches 0. As this step gets smaller and smaller, as this offset gets smaller and smaller, we get the actual slope of the tangent line instead of an approximate slope of a secant line. That's what's happening. That's the concept of the derivative. That's very important to get. Okay, so that's what I did over here. Now, how is this the same as this? Well, you just change up the definition of the points. That's all it is. Let me draw it one more time. So I'll just draw this section over here, okay? This is my C over here. Okay, that was here. Okay. And now we take some offset points, nearby offset point. Let's call that X. Instead of C plus H, where H is the step, we just call that whole thing X instead. Okay, so we have some f of C and some f of X as well. Okay, what's the slope? It's f of X minus f of C over X minus C. Change in Y over change in X. And as this point approaches C, the slope gets closer. So let me draw the line again. So this is, let's say this is the slope, the purple one again. Hopefully on camera you can see the colors. This is the secant line approximation, and then as we get closer, you'll see this, the slope of this line will get flatter and flatter to match this purple one. So we take the limit as X approaches C. Exact same as this. So you just define the point a little differently. Again, this is the twin analogy that I tried to use. Exact same DNA, exact same concept, but they look a little different in the formula. Okay, and that's it for this video. Hopefully this was helpful to show that these two are the same and to just review the conceptually what is the derivative. All right, please like and subscribe as always if you found this helpful.